Okay, so what we're going to start doing is we've been looking at obviously sequences, and we knew the way to write out a rule and give the starting term is we can use this recurrence relation formulas. So now what we're going to look at is different types of sequences. So when we have, and the two ones we're going to look at, we have like an arithmetic. This is when you're either adding or subtracting an amount. So your rule will have either it's just adding or subtracting an amount. And then if you have, and another one we're going to look at is geometric sequence. And this is when the rule will be when we're multiplying by a number, yeah, or a value. Okay, so what we're going to say when we add, so when we look at it, so here we've got the arithmetic sequences. When we're adding something to the term before, so if we're always going to say, for example, we're adding 5, the terms are going to get bigger, aren't they? They're going to grow. So when we say we have an arithmetic growth sequence, I'm going to put an example in here so that you know. So say, for example, we started at 3 and our rule would have been that we, I'm going to say we add 2. So you can see here's the bit we're adding, and because it's getting bigger, see how this would be the value. We keep getting bigger. So say if I wrote out the sequence, it'd be 3, 5, 7. So this is growth. So the numbers are getting bigger. Okay, so we know it's growth when the numbers are getting bigger. Now, so this is an arithmetic. If we subtract the same number, it's still an arithmetic sequence, but it's getting smaller, isn't it? If we take away, and what we say when we take away, that's called decay. So if you, we're minusing a number is decay, and the sequence, the numbers are getting smaller. So I'll show you what an example of an arithmetic decay one. So say I started at 10, and my rule, what you're going to see is we're going to, I might say, I'll do -2. So you can see it's going to get smaller because we're minusing. So if I set out my numbers, it would be 10, 8, 6. So you can see, and so on, they're getting smaller. So that's arithmetic. So that's that one down there. They're the ones we're going to look at first, but we will, while we're here, we'll have a quick little talk about geometric. So that's when we're multiplying. And what we call, when the number that we're multiplying is called a common ratio. So just write, if you want to write it, this is the number you're multiplying with. Okay, so if you multiply by a number greater than 1, your numbers get bigger. So say, for example, I'm going to say VO is 10, and I'm going to show you a geometric. So what about if I said 2 times VN? So you can see this number is greater than 1, isn't it? It's bigger, greater than 1. So we're going to see growth if we wrote out that sequence. So if we wrote out that sequence, we'd have 10, 20, 40, 80. So you can see it's growing. So it's not growing by the same amount, is it? But what it is, it's the same, what we say is the same ratio. When we're doubling it, we're actually timesing it, so but it goes up differently, doesn't it? Because if you look here, this one goes up by 10, but this one goes up by 20, and this one goes up by 40. So where over in the other one, it was going up by the same amount. So that's the difference between, you can spot the difference. Okay, if you have decay, so you're timesing it still, so I'll say I'm going to times it, but you times it, the rule will be you're timesing by a number less than 1. So say I go 0.5 BN. So we might indicate here that's less than 1. So we'll see decay. So say if I start at 100 and I times it by 0.5, I get 50, don't I? And if I times 50 by 0.5, I get 25. So you can see we're decaying. It's getting smaller. Decaying, you might write getting smaller, just so you get used to what that means, that word. Decaying means that the values are getting smaller. Okay, so if we have geometric, we're timesing with a number. If we have arithmetic, we're either adding or subtracting. Okay, so here if we look at this little example down here, let's see if we can just work it out. If we look at this, if we've got some examples. So can you see the first one? The growth is, it's growth and it's arithmetic because we're adding the same one, yeah? So can you see we got, the next one is arithmetic, but it's decay because it's minusing 100. But it's the same amount, isn't it? But if we look here and we look down here at our geometric, so if you're timesing by 6.5, is it going to grow or decay? Grow. So that's why that one's a growth. And when we're timesing by 0.65, it's less than 1, so it's going to reduce, decay. Yeah? So that's all you just need to be able to spot that. All right, so we're going to look at just at linear growth. So this is just another word for arithmetic. So let's write that. Okay? So when we say we're going to model, so that means we're just going to use real life examples of sequences, and that's what modeling means. Okay, so what we're going to do, let's remind ourselves when we have arithmetic growth, this would be adding an amount, yeah? And this one will be minusing an amount. Maybe if we should even say the same amount, so it'd be a certain number. So what we're going to do is we're going to see these arithmetic sequences or linear sequences. We're going to write them out in the recurrence formula. So you can see when you have a growth one here, you can see this will be the formula. And can you see the D is getting added? That will be that same amount. So let's just put a little example so you know. So you'll see, say we had 100, and then we would have, the formula would be maybe Vn plus 20. So that D, in this example, D, I'll do a capital D. In this example, D is equal to 20. That's the same amount that's getting added every time. Okay? If you see here when we've got decay, you can see in the recurrence relation, it's minusing. So say if I did an example next to it of a recurrence relation, we would see it, say minus 30. So the D equals, the difference is still 30, but it's getting minus. Can you see? And those two are different. So our first one we're going to model is the adding one. So when we're adding the same amount, and what that, and an example of that in real life is a simple interest scenario. So simple interest is when we calculate, say we have $100 and we say we're going to give you 20% interest, simple interest on that $100. So what's 20% of $100? 20. So what's going to happen if we say that simple interest is calculated on that initial value, so the starting 100, and every whatever you say, if we were going to get simple interest yearly, we're going to add $20 every year. It will always be $20. That's what simple interest is. So it was calculated from that original amount, so it's always the same amount. okay? So what we're going to see, so a fixed amount of interest is paid at regular intervals. So if you want, you might see that's going to be the D in the formula, yeah? That bit they're adding on every time. Now, the principal, you'll hear them sometimes use the word principal. So take note, it says the VO, or we're going to, maybe if you say this is the starting value, yeah? So what I said before would have been $100. VO would have been 100, okay? Now, that amount of added interest is usually a percentage. So how we work out that amount is, or often we'll say simple interest, you're going to get 20% of that original, or we'll tell you what percentage. So see here, if I just did that example I said before, I'm going to write it down for you. So VO was, I said $100, and then we ended up saying, if I said it was 20%, it would have been that. So let's have a look. I'm going to say, so here, if we were working out that D value with what I said you're going to get 20%. So here in that formula is where we're going to put the percentage over 100 times our initial value, which was $100. That's what I said. And that's how we worked out D was 20. So 20 was going to be added. Okay? So here's this. When you're going to write the recurrence relation or the formula, you're going to have to write this, what's in the yellow, but you're going to have to calculate what D is first and then work out. So what we did then in our heads, we worked out 20% of 100 was $20, so we knew that D was 20. But that's essentially what we did in our heads. All right, it all makes sense once we do a few, okay? Always a bit daunting at the start. Okay, so just so you know, if this was, if you graphed your simple interest, so this could be the value of your simple interest, say investment or whatever. Okay, so if you look, because it's going to be, and take note, when you have a simple interest, it's going to be a straight, it's a straight line, yeah? It's a straight line, and that's because it's always adding the same amount, yeah? So sometimes same amount being added. Okay, because sometimes they give you a graph and they might say what one is this. So if it's a straight line going up, it must be growth and it must be arithmetic or simple interest. So we can have a look if it's a straight line. Don't worry about these. They're just there. We'll look at them later when we get a bit more into it. They're just formulas ready for you. Okay, so here's an example and let's work through it. So Michael gets a loan from the bank for $7,000. So this is, we can still get a loan, and we're still going to pay. It's like still going to grow because the bank makes us pay for borrowing the money. So if you think of this, we're thinking about how much we have to actually owe or pay back at the end of it. All right, so he gets a loan for $7,000. So when they say the start bit, that's going to be your VO. That's your beginning amount, okay? So even if you want to write, because this is in our notes, so we can write a little bit here. So this is the beginning amount they just gave me. And then it said it's charged at simple interest. Now this is going to become crucial that you know which one you're looking at. They're always going to tell you, so we need to make sure we're underlining that. Because at the end of this, I'll have a summary formulas for you, and all you need to know is like we're going to this formula. All right, at a rate of 7.4% per annum. So in our formula on the previous page, this is the R. They referred to the rate, the little R. That's our rate per annum there. Okay, so it says model this recurrence relation using Vn plus 1 and Vn. We know that's how we've been doing it anyway. So when we have a recurrence relation, we have to write VO And then we got to write the Vn plus 1 equals. Now, on the previous page, they showed us what the formula was. I'm just going to grab it. Okay, so boys, on the previous page, this was what they said to do for the simple interest if we have to write a recurrence relation. Okay, so on the thing, it's told us on our other page, we know simple interest, and this is what we have to for the recurrence relation, okay? So this is what we're gonna, I'm just abbreviating that there. Okay, so we have to write the VO, the original amount. So I can see up there it's 7,000. And then the next thing I have to do is write this formula. And remember, I said D's the only thing you have to calculate because it's and it's highlighted blue for that reason. So if you went back and had a look at what it said that this is how you calculate D. So in this example, what was my R? What was R in this example? 7.4. So we go over 100. And what was my VO? What was my initial? 7,000. So do that on the calculator. And what do you get? All right. So it ends up being 518. So you know that's what D is. So when we go and fill in our recurrence, we're going to write Vn plus 518. So there's what you have to fill in. And that's the answer. That's what you've done. Okay, and then it says use this recurrence relation to find the value of the loan after 1, 2, and 3 years. So this is where we can do it in our calculator again. So I've popped in the first one, press enter, so that was VO. Then the rule says to add 518, so you'll see here you'd get answer plus 518. So we get that, that's V1, that's 1 year. This is V2 after 2 years, and this is V3. So our answer would equal $8,554 after 3 years. Okay, use your calculator to determine how many years it takes for the value of the loan to be more than $10,000. So what you have to do is keep pressing enter, and what do you get? Keep pressing enter. So it was V6. What did V6 equal? So V6 ends up 10,108. So we're going to say after 6 years. Now, if it says write down a recurrence relation if the model is 15,000 and has borrowed a simple interest rate of 3.8% per annum. Okay, so with this one, we've got to change it up. We've just got to do a recurrence relation. So VO is always what we initially started with. And then we're going to write, now this is simple interest, so we would have gone and found this formula. So is what I need to write, but obviously we need to calculate this D. So I'll go work that out, and we write the formula. So this time it's 3.8. Okay, so what does that equal? Did it really? Okay, 570. So this rule would actually be, I'm just going to rub that out. It's going to be 570. So we calculated that was our D, yeah? And we've found that over here. Okay, Cheryl invests $5,000 in an investment account paying 4.8% per annum at simple interest. The model of this simple interest investment is using the recurrence relation. So they want you to model this, and they've been nice and they've given us our formula anyway. So I don't need to go look it up. So I know for a recurrence relation, I've got to write the VO, which is the 5,000, and then I'm going to write that rule, which is going to be Vn plus. Now, I've got to work out that D, because that's the bit I need to, and they've given me the formula there anyway. So D equals 4.8 over 100 times 5,000, and what does that end up equaling? All right, so it's 240. So this is what you need to have written there. This is the answer. Okay, Cheryl's simple interest investment is modeled there. The value of the investment after n years, so Vn equals years, how many years? Use the model to determine the value of Cheryl's investment after 3 years. So this is where you have to step it all out because they've said use the model and show. It's pretty much showing. So what you're going to have to do is you have to write after 3 years. So we'll just write VO is 5,000. And how do we get V1? We get the one before and we add 240. So that would be 5,240. Then we're going to get V2, which would be 5,240, add the 240.
480.
Yeah. And then we need 3 years, so we need V3. So 5,480 plus 240, which is 5,720. Okay, that's what you have to show for that one. Then in B, when will Cheryl's investment first exceed 6,000? And so what you have to do, just do it on your calculator. Click through. When did we find it to be? V5. And what was V5 equal to? So we're going to say after 5 years.